June 15, 1944. 800 hours. A sprawling American depot near Normandy, France. Grey skies hung low over the captured vehicles, like a funeral shroud. Captain James Richardson, 34 years old, chief tank analyst for the United States Army Ordnance Department, stepped out of a covered truck, his leather boots crunching against gravel still wet from overnight rain. Intelligence had delivered something extraordinary. A pristine German Panther tank, barely 3 months in service, abandoned intact when Wehrmacht forces retreated from advancing American columns. No explosives, no sabotage. A technical gold mine, or so Richardson believed when he received his classified briefing that morning. He had examined captured German equipment before, always finding clever engineering, admirable precision. But this morning his commander had added a peculiar phrase: "Take as long as you need, Captain. We need to understand something." The way it was said suggested they already knew the answer. James Richardson was no ordinary infantry officer. 12 years with the Army Ordnance Department, 2 years as primary evaluator of enemy armor technology. Before the war, he'd worked at the Lima Locomotive Works, studying manufacturing processes and metallurgical limits. His father had been a chief engineer for the Bethlehem Steel Corporation. Steel and mechanics ran in his blood like oxygen. His expertise wasn't in combat tactics or strategy. It was in the brutal mathematics of what machines could and could not do. He understood stress tolerances, alloy compositions, production bottlenecks. The American doctrinal assumption was that American tanks were adequate. Good armor, adequate firepower, superior production numbers. Germany, they were told, had created a few superior specimens, but American industry would overwhelm them through sheer volume. Richardson had never questioned this until he saw the Panther at first light. Something in his chest tightened. What Captain Richardson was about to discover would shake this assumption to its foundations. The Panther wasn't just a better tank. It represented a design philosophy so fundamentally different, so systematically superior in execution, that it revealed an uncomfortable truth. American tanks weren't adequate. They were functional compromises. And the source of that difference wasn't mere tactical innovation or superior metallurgy. It was something both more terrifying and more obvious. The German industrial machine had produced a tank that American industry shouldn't have been able to face. The question Richardson would grapple with all morning, and for the rest of the war, was whether anyone with authority would believe him, and whether if they did it would matter. Richardson approached the Panther with a team of 3 subordinates, clipboards in hand, measuring instruments in canvas bags. At first glance, it resembled their own M4 Sherman, a tracked vehicle, sloped hull, rotating turret. Same basic architecture, identical tactical concept. But as he stepped closer, his eyes began to catalogue details that made his stomach tighten. The armor plating began his analysis. The Sherman's frontal plate, 51 millimeters at a 56-degree angle. The Panther's frontal plate, 80 millimeters at a 55-degree angle, 56% thicker. Richardson ran the calculation in his head, effective armor thickness against a typical anti-tank round. The Panther's sloped configuration gave it nearly twice the resistance. "Take measurements," he ordered quietly. "Check for welds. Check for heat stress." The gun came next. The Sherman mounted a 75 millimeter cannon, a respectable weapon that had served adequately against earlier German tanks. The Panther, 75 millimeters as well, but the barrel was longer, 70 calibers versus 52. Richardson examined the muzzle carefully. This wasn't a different gun in the same mounting. The entire construction was precision engineered for higher muzzle velocity, at least 15% increase in projectile energy, possibly 20. "Sir," his junior officer, Lieutenant Patterson, interrupted his calculations. "There's something about this turret ring." They examined the junction between hull and turret. The ring diameter measured 1,650 millimeters. The Sherman's, 1,450 millimeters. Larger internal volume meant room for more sophisticated fire control systems, larger ammunition magazines, better crew ergonomics. Richardson found himself searching for compensations, weaknesses to balance the advantages. Every tank had compromises. Weight versus speed, armor versus mobility, firepower versus ammunition capacity. The Germans had to have sacrificed something. The engine compartment revealed a Maybach V12 diesel, producing approximately 700 horsepower in its current configuration. The Sherman's radial engine, 425 horsepower. The Panther weighed approximately 45 metric tons, the Sherman, 33 tons. Power-to-weight ratio, Panther at 15.5 horsepower per ton, Sherman at 12.9. The Panther accelerated faster for its mass. The gap closed when considering the Sherman's higher revolutions per minute, but not enough. Not nearly enough. "Captain," Patterson said cautiously, "these specifications, they're not experimental. Look at the wear patterns. This vehicle has been in active service." Richardson nodded slowly. "Production model. This is serial number 1623. They've made over 1,600 of these." He'd seen this truth confirmed when the intelligence brief mentioned recovery of 5 additional Panthers in the past week alone. 5. Not prototype specimens. Production vehicles, all demonstrating identical or superior specifications. The final calculation hit him like a physical blow. How Sherman firing its 75mm round at a Panther's frontal armor at close range. Effective penetration unlikely at angles beyond 600 meters. But a Panther firing at a Sherman at the same distance. The superior velocity and armor-piercing capability meant engagement ranges where the American tank couldn't penetrate German armor before taking lethal hits itself. "It's not luck," Patterson whispered, understanding the mathematics. "It's design. Systematic design." Richardson stared at the vehicle for a long moment. "Document everything, all measurements, all observed quality of manufacturing, and request the intelligence files on production capacity." He paused. "I need to understand how they're building these." The second captured Panther arrived that afternoon from a different sector. This one had suffered track damage, but was mechanically intact. Richardson's team repeated their analysis systematically, same specifications within acceptable manufacturing tolerances, which themselves spoke to remarkable precision. German production couldn't sustain the variation typical of American factories operating at maximum capacity. The third tank, examined the following day, told the same story. Then they received reports of a captured Tiger I tank, Germany's heavier design weighing 56 tons, with 88mm gun, even thicker armor. Richardson examined the intelligence photos before seeing the actual vehicle. "It's not one tank that's superior," he told his commanding officer that evening. "It's the entire production line, every component manufactured to tolerances that shouldn't be sustainable at scale. The armor penetration capabilities across their heavy and medium tanks, they've engineered them systematically. No trade-offs, they built tanks that refused to accept the usual compromises. The search for compensatory weaknesses yielded nothing. German engines, while complex, demonstrated reliability. Transmission systems, though different from American designs, functioned effectively. Fire control systems showed sophistication beyond American standards. The guns were better, the armor was better, the automotive design was better. What was most disturbing was the absence of any system that suggested corner cutting. American tank production had accelerated dramatically since 1942, yielding numbers that dominated in sheer count. But those numbers had come through manufacturing shortcuts, component standardization for speed, acceptance of mechanical variability. Every Sherman represented a compromise between production speed and mechanical excellence. The Panthers, at least the production models being recovered, represented no such compromise. Richardson pulled declassified intelligence reports covering German tank production from 1943 onward. The numbers swam before his eyes. Germany had committed massive resources to the Panther program specifically because their analyses suggested that tank superiority, not numerical superiority, would determine armored warfare. They'd accepted lower production volumes in exchange for such overwhelming per-unit capability that each German tank would destroy 2 or 3 Shermans before being destroyed itself. The math was unambiguous. A German tactical doctrine of armor superiority multiplied through production figures meant that any engagement would favor German forces at the unit level, even when Americans achieved numerical advantage at the strategic level. Before we continue with what Richardson discovered next, I want to hear from you. What's the most surprising WWII tank technology you've learned about? Drop a comment below and let me know where you're watching from. And if you're finding this technical analysis fascinating, hit that like button. It helps more history enthusiasts discover these stories. By the fifth Panther examination, Richardson had compiled comprehensive data on what he considered the most extraordinary system, the Panzer III's hydraulic stabilization system for the gun turret. American tanks mounted their guns without stabilization. Crews compensated through training and technique. German engineers had developed a hydraulic system that maintained gun aim even while the tank moved across rough terrain. This capability was revolutionary. It meant German tankers could engage targets effectively while maneuvering. American crews were forced to halt before achieving accuracy. The advantage was incalculable in combat conditions. Richardson knew why this mattered so profoundly. American engineers had been attempting gun stabilization for 3 years. The technical challenges were staggering: hydraulic fluid instability under temperature fluctuation, precision tolerances requiring manufacturing capability that exceeded American tooling standards for rapid production, seal reliability problems that had caused catastrophic failures in prototypes. The Americans had abandoned the program as technically unfeasible within wartime manufacturing constraints. Yet here was a German production tank, manufactured in quantity, with a stabilization system that functioned reliably. Richardson examined it with near-religious attention: the hydraulic pump assembly, the governor mechanism, the damping system that prevented oscillation. Every component precisely engineered, every seal flawlessly executed. "This should be impossible," Patterson said quietly, watching Richardson measure hydraulic tolerances. "Our people said it couldn't be done with existing industrial base." Richardson didn't respond immediately. He was calculating what would be required for American industry to replicate this. First, retooling hydraulic factories, 6 months minimum. Second, developing seal materials that could maintain specifications under temperature stress, another 4 months of research and testing. Third, integrating the system into production schedules without disrupting overall output. Impossible. The production lines would have to be redesigned, workers retrained, new quality control procedures implemented, an entire industrial reorganization. The Germans had somehow solved every obstacle. When Richardson presented his findings to Army Ordnance Headquarters, he included a formal assessment. German armor production has achieved technical specifications in firepower, armor protection, and operating systems that American production cannot currently match. The Panther tank represents approximately 20% tactical superiority per unit across multiple key parameters. German Tiger tanks represent approximately 40% superiority. The response was silence, followed by his commanding officer suggesting that perhaps Richardson was allowing captured German propaganda to affect his objectivity. But Richardson had barely begun his true revelation. The numbers hadn't appeared yet, the statistics that would transform concern into terror. It was July 1944, when Army intelligence delivered the production statistics that changed everything. Richardson sat in a secured briefing room with maps, charts, and classified reports spread before him like pieces of a catastrophic puzzle. The numbers were these: Germany was producing approximately 380 Panther tanks per month in 1944. America was producing 2,150 Sherman tanks monthly in the same period. The ratio appeared favorable on the surface, nearly 6 Shermans for every Panther. But Richardson's calculations transformed that ratio into something far more troubling. If each Panther required the destruction of 2.4 Shermans in combat, a conservative estimate based on armor and firepower analysis, then American production would require increasing output by 24% just to maintain attrition balance. At current casualty rates in northwestern Europe, American tank losses exceeded replacement by 8% monthly. The calculation repeated itself through multiple vectors. Gun ammunition production. Germany was manufacturing 88mm armor-piercing rounds at approximately 14,000 units monthly. America manufactured 75mm rounds at 67,000 units monthly, but faced the problem that most American rounds lacked the penetration capability to defeat Panther armor at normal engagement ranges. Armor plate thickness requirements. German factories had shifted to manufacturing thicker steel plates for tank hulls. increasing per-vehicle weight by approximately 2.5 metric tons across their production lines. This represented a massive commitment of industrial capacity, yet they were sustaining it. American factories had not increased plate thickness standards since 1942, meaning American tanks continued rolling off production lines inferior to those they would encounter in combat. Engine production. German Maybach engine factories were maintaining quality standards while increasing output. American radial engine plants, facing pressure to maximize numbers, had reduced quality control standards twice in the previous year, resulting in engine reliability rates that dropped from 94% to 87%. German reliability rates for comparable engines remained above 96%. Raw material consumption. Panther production required approximately 1.2 metric tons of aluminum per vehicle. Germany was securing this through aluminum plants in occupied territories and sustaining monthly output of 456 metric tons for tank manufacturing alone. American aluminum allocation to tank engine manufacturing was 380 metric tons monthly. Germany was outproducing American tank aluminum consumption while simultaneously supplying fighter aircraft, bombers, and other military equipment. The cumulative picture appeared across multiple briefings throughout July and August. Germany had restructured its economy around the principle that armor superiority would overcome numerical disadvantage. Every German tank design decision embodied this principle. Every manufacturing commitment supported it. The industrial reorganization had occurred in plain sight, documented in intelligence reports that Richardson's superiors apparently hadn't actually read. Richardson began the calculation that would occupy him for weeks. How many Shermans would be required to sustain current casualty rates against expanding German tank production if the technical gap continued widening? The mathematics suggested a ratio approaching 3 to 1, then 3.5 to 1. American production would need to increase by 40, perhaps 50%. Yet American production was already at maximum capacity. Tank factories were operating 24-hour schedules, running at 92% efficiency, the remaining 8% reserved for equipment maintenance. Increasing output further would require new factories, new workers, new raw material allocations. The industrial machine was already consuming the available resources at maximum rate. Germany was committed to a strategy that mathematics suggested should fail, superior technology attempting to overcome numerical disadvantage. But the fundamental problem was this: Germany was succeeding. In every tank versus tank encounter in Normandy and emerging accounts from the Eastern Front, German tanks were destroying American and Soviet tanks at ratios that exceeded expectations. The technical superiority was translating into tactical reality. Richardson compiled his findings into a classified report titled German Tank Production Capacity and Technical Specifications Strategic Assessment. He submitted it with a conclusion that he knew would be rejected. Current American tank designs are tactically inadequate when facing German armor production. American victory in armored warfare requires either A. Massive increase in production beyond current industrial capacity, B. Significant redesign of American tank specifications to match German technical standards, or C. Tactical restructuring that minimizes tank versus tank engagement accepting terrain and strategic positioning as primary advantages. The current doctrine of numerical compensation for technical inferiority cannot be sustained beyond 1945 if German technical advantages expand further. The numbers Richardson was seeing were staggering, and they painted an undeniable picture. If you're enjoying this deep dive into the industrial side of WWII, make sure you're subscribed to the channel. We release new technical analysis videos every week. And drop a comment. What aspect of WWII history fascinates you most? The technology, the strategy, the human stories? I read every comment. Richardson's report circulated through Army Ordnance channels in August 1944. It was marked classified and distributed to 12 officers above his command level. The official response arrived in September. His analysis was noted and filed. No formal reply, no request for additional information, no strategic directives based on his findings. Instead, he received an informal message through his commander. "Captain, the assessment is probably accurate, But the brass aren't prepared to receive this kind of information right now. It was a peculiar moment in Richardson's career, the moment when he understood that institutional effectiveness and tactical reality were not necessarily connected. The American military apparatus had commitment to victory, but that commitment operated on strategic timelines and industrial capacity assessments that had been established years earlier. Altering those assessments mid-war meant acknowledging that previous estimates had been incomplete. The problem wasn't that American military leadership was incompetent. The problem was bureaucratic. The system that had been established to wage war was now trapped within its own parameters. Increasing tank production required congressional appropriations that required justification, which required admitting that current production was inadequate, which required admitting that current designs were inferior, which required admitting that previous strategic assessments had been wrong. The psychological and institutional weight against such admissions was substantial. Richardson watched as tank production statistics for the remainder of 1944 remained unchanged. No new tank designs were rushed into production. No emergency appropriations were submitted. The American military continued pursuing its original strategy: outproduce Germany numerically and compensate for technical inferiority through overwhelming force application. By November 1944, German tank losses in the European theater had begun to increase, not because Sherman tanks had become more capable, but because German forces were engaging in increasingly desperate tactical situations with insufficient fuel and stretched supply lines. German tank production, meanwhile, had actually increased. As of November 1944, Germany was producing 410 Panthers monthly, having optimized the production process further. American production remained at 2,200 Shermans monthly, nearly identical to July levels. Richardson was promoted to major in late 1944 and transferred to the Pentagon to work on post-war tank development strategy. As he departed the Ordnance Depot in England, he submitted a final report marked Final Assessment. German technical strategy has been validated by operational results. American numerical strategy has achieved only parity in casualties, not superiority. Post-war armored development should prioritize technical match rather than numerical compensation. The report was filed. It was never formally reviewed by anyone above the rank of colonel. It was never cited in subsequent strategic documents. It simply existed. A classified memorandum that contradicted the narrative that American industrial superiority would inevitably overcome German technical sophistication. Between December 1944 and March 1945, the Ardennes offensive and subsequent campaigns in Western Europe provided operational validation of Richardson's technical analysis. When Panther tanks encountered Sherman formations, the engagement results followed predictable patterns. German tanks consistently achieved approximately 2.3 enemy tanks destroyed per German tank lost. In some encounters, ratios reached 3.1 or 4.1. American losses accelerated. Monthly tank casualties rose from 380 units in October 1944 to 680 units in January 1945, and 79% increase. American production, meanwhile, remained fundamentally unchanged. The cumulative deficit in armored strength grew month by month. Richardson, now analyzing data from Pentagon intelligence channels, watched as his numerical prophecies materialized. In March 1945, he was invited to brief the War Department's Strategic Assessment Division on current armored capability ratios. He presented comprehensive data showing that American armor production was now falling 14% behind replacement requirements, a deficit that was widening. "What's your recommendation, Major?" asked the Brigadier General chairing the committee. "Escalate armor production by 35 to 45%, or restructure tactical doctrine to minimize tank versus tank engagement," Richardson responded. "Current trajectory cannot be sustained another 6 months if German technical advantages expand further." The response was pragmatic. "Germany is collapsing, Major. Their oil production is destroyed. Their supply lines are fragmenting. We don't need to match them technically. We just need to maintain numerical advantage while they run out of resources." It was accurate. By March 1945, Germany's industrial capacity was declining rapidly due to Allied bombing campaigns targeting fuel production and manufacturing facilities. German tank production would indeed fall by 47% between March and May 1945. But Richardson's underlying technical assessment remained valid. Germany had created a tank design superior to American design and had maintained production of that superior design despite overwhelming American numerical advantage. The reason Germany wasn't dominating the war wasn't technical or industrial. It was strategic overextension and resource depletion due to fighting on multiple fronts simultaneously. His prophecy had been confirmed. American industrial power could overwhelm German technical superiority, but only through attrition, waste, and the destruction of an enormous number of American soldiers. On May 7, 1945, Germany surrendered. The post-war analysis began. When classified documents were declassified after 1950, historians and military analysts examined the production statistics that had defined the final years of European warfare. The numbers confirmed Richardson's analysis precisely. Germany produced 8,500 Panther tanks across all variants between 1943 and 1945. America produced 49,234 Sherman tanks across all variants in the same period. Ratio, nearly 5.8 to 1 in America's favor. Yet German tank losses in the European theater, when examined carefully, revealed destruction ratios averaging 2.4 American tanks for every German tank destroyed, precisely Richardson's conservative estimate. Detailed analysis of the Ardennes offensive showed American tank losses of 1,400 units against German losses of 1,100 tanks and tank destroyers. In that campaign, the technical superiority of individual German vehicles had been demonstrated operationally. American victory was achieved through strategic depth, not tactical advantage. Post-war interrogation of German officers confirmed what Richardson had deduced from captured equipment. The Panther had been specifically designed to provide technical compensation for numerical disadvantage. Every design decision, armor thickness, gun specifications, hydraulic systems, engine power, had been made to maximize per-vehicle lethality. In 1952, when preparing the classified history of armored warfare for the Pentagon, military historians discovered Richardson's original reports from 1944. His analysis was footnoted in the final assessment. Major Richardson's technical analysis correctly identified that German tank specifications exceeded American specifications across multiple critical parameters. His prediction of casualty ratios proved accurate when validated against operational records from the European theater. The reports were marked declassified in 1978. Richardson himself survived the war, was discharged in 1946, and returned to engineering work in private industry. He worked on the M47 Patton tank development program and consulted on the M48 design, tanks that finally incorporated the technical specifications he'd recommended in 1944. When interviewed briefly for a military history oral history project in 1982, Richardson was asked if he'd experienced frustration that his warnings in 1944 hadn't been acted upon immediately. He paused, then answered carefully, "The institution made the decision it had to make. Changing production schedules mid-war meant accepting that previous decisions had been incomplete. That's a difficult institutional acknowledgement to make. They chose to proceed with existing parameters and win through attrition rather than redesign. It was strategically valid. It was just costly." The historical record proved Richardson right in every detail. If this kind of detailed technical history interests you, you'll love our other videos analyzing WWII equipment and strategy. Check out the playlist in the description. And before we wrap up with the bigger lesson here, hit that like button if you appreciate this level of research and detail in history content. The story of Major James Richardson and the Panther tank is a microcosm of a larger historical pattern, the tension between objective reality and institutional narrative. Richardson identified truth through technical analysis and data. The institution that received his findings was committed to a narrative established before the technical evidence appeared. The collision between those two forces defines much of what happened in technological warfare during the final 2 years of the European campaign. This pattern repeated across multiple dimensions of the conflict. Admiral Ernest King's warnings about convoy losses in 1942 were initially dismissed because they contradicted strategic doctrine about battleship supremacy. General Mark Clark's assessments of Italian defensive capabilities were dismissed as excessively pessimistic before Salerno revealed them to be conservative. Multiple intelligence analysts identified German wonder weapons programs early. Their warnings were marginalized because they contradicted the narrative of American technological superiority. The common mechanism was consistent. Competent individuals recognized uncomfortable reality. The institutional system dismissed that reality because accepting it would require acknowledging that previous decisions had been incomplete or incorrect. The pressure to maintain narrative coherence, institutional legitimacy, and established strategic doctrine was more powerful than the pressure to adjust course based on new technical evidence. The consequence was inevitable. Reality eventually overcame ideology, but not before significant waste of resources, casualties, and time. Richardson's original recommendation, emergency tank production increase combined with strategic redesign, would have been more efficient than the attrition approach that was actually pursued. Yet from an institutional perspective, the American approach was rational. Fighting a war on the principle of numerical compensation for technical inferiority is strategically sound if your nation possesses overwhelming industrial capacity. That's precisely what America possessed. Germany's strategy of technical compensation for numerical disadvantage was militarily sound in isolation. The problem was that Germany was simultaneously fighting on multiple fronts against adversaries possessing both technical and numerical superiority. Neither strategy was wrong. Both were rational responses to different strategic circumstances. The lesson is more subtle. Institutional systems have difficulty incorporating technical evidence that contradicts established narrative, even when that evidence is accurate and presented by credible analysts. The question Richardson couldn't definitively answer, and which remains historically unresolved, is whether altering American strategy in 1944, based on his analysis, would have accelerated American victory significantly, or whether existing industrial capacity was sufficiently overwhelming that the attrition approach remained optimal despite its inefficiency. What is definitive is this: Germany produced technically superior tanks. America won through producing vastly more adequate tanks. The industrial triumph was real. The human cost of that triumph, measured in burned-out Shermans and casualties, was the price of institutional inflexibility in a war where technical reality was suggesting that flexibility was required. Thank you so much for watching this deep technical analysis of WWII armor strategy and industrial power. Major Richardson's story reminds us that numbers aren't the only measure of military capability. Sometimes it's the brilliance behind the blueprints that changes everything. If you enjoyed this exploration of how American industrial dominance actually overcame German technical excellence, please hit that like button and subscribe for more detailed military history analysis. We release new videos every week, examining the intersections of technology, strategy, and human decision-making throughout World War II. And while you're here, I'd love for you to check out the video appearing on your screen right now. It covers another fascinating aspect of WWII's industrial war. Thanks for your time, and I'll see you in the next one.